Dear viewers, greetings of the day to all. And in today's topic of power system, we are going to discuss about the topic unit commitment and economic load dispatch. Unit commitment and economic load dispatch are the very hottest topic and mind-storming topic across the power systems, which involves number of scheduling units for the power system operators for generating the amount of load required and which is coming under the topic of unit commitment, and followed with the unit commitment we are going to discuss about the economic load dispatch. Okay, in economic load dispatch it is a very interesting and important topic of our system, in which how in what manners the generated loads are dispatched to the consumers across the tail ends of the across all the starting from bulk consumers to the medium and followed with the low level consumers. Okay. And while coming for unit commitment, the very first statement for producing unit commitment is that we have to select the number of generating units which will supply the forecasted load to the system required for running a minimum cost of operating units. Okay, this is a simple terms and it deals about the unit commitment technique. And followed with the unit commitment, what is the current scenario and what will be the tomorrow scenario in power system operations, and what are the things to be determined while following the unit commitment problem. First of all, we have to determine the number of available units, which can be stated as a n number of units. Okay, the n represents the total number of units which are running across the power system for generating the power. Okay, the power may be obtained from the all the forms of fossil fuels, or else from the hydropower plants or thermal power plants and etc. Okay, these are the total operating units which will be operating for power generating section, and then the n also represents the number of units which are shut down for the power generating. Okay. In power generation, the costs which are two main costs involving the power systems are, the one is the operating cost and another one is the running cost. Okay. The main so while going for unit commitment and economic load dispatch is to limit the number of operating units for reducing the operating cost as well as the running cost in order to produce a maximum power output across the total number of units. This is a simple concept behind the unit commitment. And while going for need, what is the need for unit commitment? This is a simple need which allows the number of reduced cost or fuel cost. Okay, we have to reduce the total amount of cost as well as the losses. The losses includes the transmission loss, operating loss, and similarly for running costs. Okay, these are all the losses which coming under the power system, and also you have to reduce the total amount of fuel cost. The amount or number of fuels which is consumed for generating the power has to be minimized. And we have another one point which I have noted is we have to commit the enough number of units for supply the connected load. Okay. At the same time, we have to, by running the maximum most economic unit, the load can be supplied for the unit to increase the best efficiency of the system. These are all the very important terms which involving the unit commitment solutions. What are the difficulties? Well, coming from difficulties of unit commitment, one of the most important difficulty is the time-consuming process. It requires maximum amount of time. Why? Because the number of units, if the number of units, the variant, okay, if the number of units is more, so the combinations will also be getting more. Okay, this number of combinations can be obtained by the simple formula of 2 n minus 1. This is a simple formula used for obtaining the number of combinations. Okay, the n can be varied from up to more than 2, 3, 4. Okay, if n is equal to 3, that means the total number of units is now number of units operating is 3. So the product of 2 and 3 will be 6 and minus 1. It represents the 5 number of combinations. Okay, there will be 5 number of combinations across the unit. So the number of if the number of combination increases, the number of operatings will also increase. Okay, if the number of combination increases, the power system becomes more complex bus systems. Okay, so there will be a maximum time consuming process for operating the system connected across the power system units. Constraints. While coming for the constraints, there are three different constraints. One is the spinning reserve constraint, another one is the thermal constraints, and other constraints which are represented as hydro constraints, which deals about the water supply city, and must-run constraints. The power system has to be run for minimum number of hours in which to reduce the total fuel cost and to operate the losses with greater efficiency. And another one constraint is the fuel constraint, which requires the total amount of fuel. The required amount of fuel must be very low. The thermal constraint involves the minimum uptime, minimum downtime, and crew constraints. Okay, the crew, the number of operating persons which are involved in the thermal constraints can be stated as the crew constraints. Spinning reserve. The very simple definition is a spinning reserve. The total to allow some parts of our system to run in either and mode is called as a spinning reserve. So this spinning reserve is mainly used for avoiding transmission system limitations for bottling up of reserves. The amount of reserve capacity involved to carry the peak load of the system is very much essential by means of spinning reserves. In case the power system is supposed to use for the supplying a peak, okay, if the peak load can be achieved across any festival time periods, there will be a huge amount of power demand across all the consumers. So that at the time the spinning reserve must be met with the power system to increase the power demand, to meet out the power demand, increase the power demand among the consumers, so that all the consumers get satisfied by the power. Reserve generating capacity. This is the reserve generating capacity which is involved across the spinning reserve, and this spinning reserve must be having the high power demand across all the generating units, and it can be supposed to for offline maintenance or repairs and refilling across all the 24 hours of the 365 days. Okay, this reserve generating capacity includes a quick diesel or turbine, gas turbine unit, and a hydro unit and pump storage unit. These are the simple reserve generating capacity for running all the units for spinning reserve constraints. While coming for unit commitment solution methods, the very first solution is the brute force technique. The brute force technique can also be simply said as a pre-ordered list method, and another one method is dynamic programming method, pre-ordered list method and dynamic programming method, and forward dynamic programming method. These are the simple topics which has been involved across the unit commitment solutions. While going for brute force technique or simple priority method, we are forming a priority list. Okay. In brute force technique, we are all having a combination. These combinations can be obtained by 2n minus 1 combination, where n stands for the number of generating units and m is a period, the total number of periods of time for each hours. M represents the hours for which each generating units are being operated. For similarly, for the unit 1 can be operated for 2 hours, and unit 3 can be operated for 3 hours and 5 hours. Similarly, for extending up to n number of units and the m number of hours. Okay, the constraints involved in the brute force technique is simply the n of units will be committed to supply your goods. Okay, if the total number of units supplied with, being supplied with particular demand, those demand has to be satisfied by means of committing the enough number of units. Okay, if the demand is 300 and the number of system being connected with maximum amount of power load consumed obtained from the unit can be of 200, 300, 500. The total, the number of units required for meeting out the 300 must be exactly the number of units, so that the wastage of power or that means like surplus power can be satisfied or it can be stored in the system itself. This can be denoted by means of simple formula P generation less than or equal to power demand. Okay, PGI less than PD. Okay, the PDA represents the power demand, PGI represents the power generation across the unit. And a feasible solution of committing some generating unit can be represented by the simple formula that means power generation is greater than the power demand. Priority list method. The priority list method can also be done by means of forward dynamic programming method. This priority list method can have a simple formula or a simple approach called as full load average protection cost, which represents the full load average protection cost represents the FLAPC. It can be represented as an FLAPC. This FLAPC is equal to CPGI divided by PGA. Okay. This can also be redefined as a KHPGI divided by PGA. Here the K represents the thermal constraints. K represents the thermal constraint and H represents the coefficient of the power generating across each unit. And PGI represents the amount of power generated across each unit. What are the assumptions? The few assumptions has to be done while going for pre-artificial list method. That is the no load cost must be zero and unit and the total number of unit which requires the startup cost will be a fixed amount and we have to ignore the minimum uptime as well as the minimum downtime constants. These are the few assumptions which has to be considered while going for pre-artificial list method. And what are the merits while coming for the merits of pre-artificial list method and demerits for pre-artificial list method is no need to go for n number of combinations. If the n is the maximum up to n, okay. If n is greater than 3, 2, 4, 5, okay. If number of combination is up to exceeding for n, there is no need to go for n number of combination. We can able to take only one set of constraint and we can able to ignore minimum uptime and minimum downtime constraint and the complications can also be reduced. Otherwise, while going for demerit, the startup costs should be a fixed amount and no need to go for variable cost systems. Okay, so and again another one demerits is that the no load cost should not be considered for running the priority list method. While coming for dynamic programming method, in dynamic programming, the unit commitment table should be tried with a reduced manner. Okay, if the number of priority is one added unit is across one, and while going for next system will be increased up to incremented up to second unit. Okay, if the number of system is followed with one system, if the system is followed with a one unit, and this one unit has to be incremented by second unit across the second stage. Okay, while going for third stage, these priority one unit and priority two unit has to be incremented with the third priority unit. Priority one unit, first of all, we will be going for first priority unit, and while second stage we are going for incrementing the unit, that means priority one unit plus priority two unit. And while going for third priority unit, we'll be going for priority one plus priority two plus priority third unit. Similarly, we will be keep on increasing the number of units up to maximum n number of units will be considered for running the n number of combinations. This is a simple priority method involved in the forward dynamic programming method and as well as for the calculating the unit commitment solution. Assumptions involved in the priority list method are the total number of units available must be assumed priorly for running the maximum number of units. This is the very first assumption. And while coming for next set of assumptions, the startup cost of the unit should be independent of time. That means we have to be fixed amount for each unit. Okay. And while coming for a third assumption, there will be no cost for shutting down of unit. If we have committed unit number of unit, there should be no cost for shutting down the unit. Okay, we must be calculating the amount for only the units which are being operating for calculating the unit commitment answers. Well, coming for advantages, there are several advantages. One is the first advantage is the algorithm must run forward in time for initial hours to the final hours. It should be running in forward manner only, and it should not go back for previous set of units while going for n number of combinations. And the previous history of units can be computed across each stages. Okay, the initial conditions of the system can also be easily specified. And while coming for forward dynamic programming, it is very suitable if the startup cost of unit is function of time and it has been in the offline, which states that the fixed amount of the system. This is the simple topic when going for the unit commitment solutions. And followed with the unit commitment, we will be going for another set of topic which is can be represented as The another first topic which has a continuation for unit commitment is about the economic load dispatch. Economic load dispatch is the topic which deals about the dispatching of load in an economical manner in order to provide a suitable solutions. Okay. This topic in economic load dispatch will be having a small brief about the presentation, which is about introduction, system constraints, characteristics, and methods of solving economic load dispatch, and followed with the loss coefficients, and we'll be having a few discussions about the previous gate questions. In economic load dispatch, the main aim of the economic load dispatch is to minimize the total cost of generating units with the most economical operation for the system. Okay, the first problem in power system is called the unit commitment, and followed by the unit commitment, we'll be having a load scheduling, which can be comprised as the economic load dispatch topic. Okay, the economic load dispatch is the online economic load dispatch problem, wherein it is comprised with the distributing the load among the generating units, actually parallel with the system of such manner, so as to minimize the total cost of the system, supplying the load from minute to minute requirements of the system. Okay, whereas while the economic load dispatch problem is also a solution technique with a large number of load flow problems and choosing one of the most appropriate solution for finding out the optimal result with the minimum cost of the generation. These are the main aims or main concepts behind the economic load dispatch. And while coming for constraints, there are the two set of constraints. One is the equality constraints, and second one is the inequality constraints. In the equality constraint, we'll be concentrating across the basic load flow equations across, which can be stated as a real power generation equation and reactive power generation equations. Okay. While going for inequality constraints, the constraints can be a set of generator constraints, voltage constraints, transformer taps constraints, transmission line constraints, and network security constraints. In generator constraints, the system operated for power generation, that means the KVA loading of the generator must be given in the formula of square root of simple equation can be given by a simple formula square root of p square plus q square, which can be a Gauss equation of square root of Gauss equations of power, real power as well as the reactive power equation. And when these equations should not, the value of these equations, that means KVA loading of the generator should not be exceed the pre-specified value of the CP, okay, which represents the temperature rise conditions. Okay, should the value of KVA loading should not exceed the temperature rise condition or value of the CP value. Okay, this is the main thing while going for the inequality constraints of generator constraints, and while going for the thermal constraint. Thermal, that means voltage constraint. In voltage constraint, we'll be having a simple voltage. That means the voltage should be lined within the minimum voltage up to maximum voltage. VP minimum less than or equal to VP. The calculated amount of VP should be lies within the minimum limit as well as the maximum limit. You should not either go beyond the minimum limit as well as the maximum limit. Okay, the voltage should be in a prescribed or optimal range, and followed the voltage minimum and maximum voltage level. The power should also be equal to the power angle must be calculated power angle voltage magnitude or voltage angle should be equal between, it should lie between the minimum limit as well as the maximum limit of the equations. So it is very essential to calculate the voltage as well as the voltage angle should be in minimum as well as the optimal condition of the systems. Next one, while going for transformer tap position, the the amount of voltage required for running the system can be provided by the transformer tap. While these transformer taps are very essential and provided across the secondary side of the transformer. So for varying the secondary output voltages across the transformers. Okay, if the input is 250, sorry, 230 voltage of input supply which is being fed across the primary side of the transformer, this 230 voltage has to be reduced or increased. That means it can be minimized or maximized by changing the transformer taps ratios. Okay, it can be done by means of a simple equation, that means a 0 less than or equal to T. T represents the tappings. Okay, T represents the tappings, and N represents the maximum number of last range of the tappings. It can be started from 0 to n number of tapping. N is the ratio of transformation. If the n value is maximum 0 to n, the value is maximum value. The amount of voltage flowing across the secondary side of the transformer will be a maximum value. Next set of constraints will be transmission line constraint and network security constraint. The transmission line constraints are very much essential in calculating the transmission loss, and network security constraints are very much essential in calculating the system violating, which involves in complexity of the constraints. If the complexity of the constraints is increased, the large number of system under the SERDI will also be increased. Okay, so it is very much essential in calculating network security constraints and transmission line constraints for solving the power flow analysis of a power system network. Like while coming for the input output characteristics. The input output characteristics is a simple graph which is being drawn plotted across the power output versus the fuel input. Okay, this is the power output USB plotted across the x-axis and fuel input across the y-axis. And this the values being obtained or the system which is running across the unit has been plotted across the marginal areas. And this simple representation of the equation or characteristics can be plotted for calculating the input output characteristics of the systems. These input output characteristics can be expressed in millions of kilocalories per hour in terms of rupees per hour versus the output voltage in the output power across the megawatts stages. Incremental fuel cost. This incremental fuel cost should be in a manner of increasing manner. If the amount of fuel cost increases with respect to the power output. Okay, if the power output increases, the fuel cost also increases. Okay, initially the fuel cost is across the minimum stages, which represent the power. If the fuel cost increases, the amount of power gradually increases to a maximum peak value and can be calculated by means of incremental fuel cost function, which can be given by given in forthcoming sessions of the subjects of this unit. While coming for the economic load dispatch solution method, there are various methods involving solutions. First of all, we have to go for neglecting the losses. Very first topic in solving the economic load dispatch is the neglecting losses. Okay, these losses can be calculated by means of a simple formula. That means Lagrangian material lambda. Lambda can be calculated by means of a Lagrangian multiplier, which represents the dF1 divided by dP1. F represents the fuel cost function, fuel input. F represents the fuel input of the system, and N represents the fuel input to the nth number of units. Okay, PD represents the total power demand and PN represents generation of the nth unit. This simple representation of these units can be calculated for calculating the total number of amounts or calculating the Lagrangian multiplier lambda. These are the very essential functions for calculating the economic load dispatch by neglecting the losses. Next, we will be going for considering the losses. These for considering the losses, we will be having a simple formula that means PD plus PL. PD plus PL is equal to power demand plus power loss is equal to total number of power generated across the nth unit. It can also be subject to some constant. That means FT is equal to Fn. That means the fuel cost across the total fuel input of the system is equal to the fuel input across the nth system. Okay, this is the system. Here the PL represents the losses. The total number of losses plus PD, the demand, can be calculated for both are being assumed for calculating the total amount of power generated across the nth number of units. Okay, this is a simple representation for calculating the power system losses. Not only for power system losses, for calculating the economic load dispatch, with including the losses of these systems. This is a simple formula which is being used for calculating the economic load dispatch with considering the losses, and these losses are being subjected with the Lagrangian multiplier lambda. This lambda can be calculated Lagrangian multiplier lambda. Okay, this lambda Pn is equal to number of power generated across the nth number of unit can be calculated by means of BMN. This is the BMN is the number of loss coefficient values. Okay, the BMN is the loss coefficient values, and lambda is a Lagrangian multiplier. Okay, this is the entire function for running calculating the fuel cost unit of the each system connected to the power system units. If the number of unit increases, the amount of loss will also be reduced, and the operating cost increases, which reduces in the minimum fuel cost of the system. The loss coefficient can be calculated by means of simple network diagrams, can be represented as A, B, C. Here, in the diagram, it is clearly shown that the units switching of each unit, okay, it represents the current is flowing across the AB1. Okay. And while going for second picture, the load is opened, the switch is opened across the first generating unit. So the second unit will be supplying the load to the all these supplies. Okay. And while going for third set of machine, both the units, both the unit 1 and unit 2 was fed for completely supplying the load to the all the system connected to the each other. Loss coefficient. While going for loss coefficient, there are two simply assumptions for deriving the loss coefficient. One is of the ratio of transmission lines are same. First one is the ratio of if the ratio of transmission lines are same, and second is the phase angle of all the load currents will be same. Okay, these are the two simple assumptions for deriving the loss coefficients, and these loss coefficient can be calculated by means of B11, B22, and B22, B12. These are the simple loss coefficient functions which can be derived from the simple equation named as P1 is equal to BP, P1 is equal to B11, B22, B2, B12, which is the combination across the first and second unit. I mean, for simple gate questions which we have, which has been asked in previous years, we have to calculate the load factor for the system. Okay. First of all, the question, the total amount of power being obtained from the system is about 2000 kilowatt. If the 2000 kilowatt power is being derived with power factor of 0.8 lagging for 12 hours and 1000 kilowatt unity power factor for 12 hours. So we have to calculate the load factor for the system. This load factor can be calculated by means of simple formula, that means actual number of units generated divided by the maximum load into total number of operating hours. Okay, from this question, it is very clear that the maximum load for the system connected is the 2000 kilowatt is the maximum load. Okay, the maximum load connected to the system is about 2000 kilowatt. Okay, 2000 kilowatt is the maximum load connected to the system. 2000 kilowatt is the maximum amount of load connected to the system, which represents the actual number of units generated. That means 2000 is operated for 2000 kilowatt is operated for 12 hours, and 1000 kilowatt is operated for 12 hours. Okay, total 24 hours can be split into 2000 kilowatts plus 1000 kilowatts. So 2200 into 1200, sorry, 12 hours plus 1000 into 12 hours. So entirely divided by total maximum load is up to 2000 kilowatt into 24 hours. So the total answer will be 0.75 unit. Load factor is equal to 0.75. Similarly, for another set of question, MD asks for calculating the incremental cost of the system connected with the generator unit, delivering 200 megawatt as follows. A simple question for calculating the fuel cost function for two power plant can be given by equation. That means P1 is equal to P1 is equal to the simple equation. C1 is P1 for plant 1. C1 is equal to 0.05 power generation square plus APG1 plus B. Okay, C2 is equal to 0.01 PG1 and PG2 square plus A3 APG2 plus 2B. This is a simple question for equation for a fuel cost function for the system connected with two set of units. Okay, now we are going to calculate the amount of power being generated by the each unit. Okay, first of all, total number of power generation between both the unit PG1 plus PG2 is equal to 1000 respectively. Okay, from this equation, we are going to derive the amount of power generation being generated by PG1 plus PG2. Okay, now we are going to calculate the amount of power generation generated by both the units is the 1000, and what will be the power generated by each unit. Okay, these 1000 can be split into two categories. One is across the power generation of second unit and another one is the power generation of first unit. So we are just going for a fuel cost function unit, that means 0.1 power generation plus A is equal to 100. Okay, and 0.2 power generation plus 3A is equal to 100. This is the simple equation which can be derived from the questions. Okay, on solving these above two equations, we can be it can be easily calculating the value of A, and based upon the value of A, we can be calculating the amount of power generation across the first unit as well as the second unit. Okay, so the 1000 megawatt of power can be easily split by the 800 megawatt for first generating unit and 200 megawatt for the second generating unit. So the amount of ratio for a power generating unit will be PG1 is to PG2 is equal to 4 is to 1 ratio will be the amount of power generated by each unit for the power system area operators. And while coming for another set of questions, we are going to calculate the incremental cost for the system operating with two generating units with the functions of P1 and P2 in megawatts respectively. We'll be having a simple characteristic equation for dC1 divided by dP1 is equal to 0.2 P1 plus 50 with respect to dC2 divided by dP2 is equal to 0.2 for P2 plus 40. Whereas a simple minimum and maximum limit for the operating units for both the P1, P2 can be given as 20 megawatt up to 150 megawatt for first unit, as similarly for second unit. Okay, from this we are going to calculate the amount of power being consumed, and that means the amount of incremental cost for the each unit. It can be determined by a simple formula, which can be given by means of dC1 divided by dP2. Okay, similarly for a dC1 2 divided by dP2 can be calculated for can be used for calculating such formulas for calculating the incremental cost of the functions. And that's all about the today's session's topic. I hope so. The topic of economic load dispatch and union commitment will be a brainstorming topic will come in the power system areas. If you have any queries or any doubts, you can ping me. Okay, you can contact me or thank you.